Example 2. Write equations given characteristics. Write an equation for an ellipse with a major axis from 5 to negative 2 to 1, negative 1, negative 2, and a minor axis from 2, 0 to negative 4. Well, if we looked at just kind of a quick graph, we could probably figure out a lot of pieces to this real quick. So we go right 5 units, 1, 2, 3, 4, and 5, and this says go down 2 units. Now it says major axis, so this is a vertex here, and the other point is left 1 down 2 units. So there's the other end of the vertex, and it says a minor axis from 2, 0. So we'll go right 2 and put it on 0, and that's a co-vertex because it's a minor axis, to 2, negative 4, 1, 2. Now once we've done this, we've actually can identify all that we need. The center will be located here in between these 4 points. We have our ellipse. So the ellipse, if we drew it perfectly, would touch all 4 of those points. This is the center here. The center is located right 2. So we'll put center is right 2 units, and it is down 2 units. Now that can help us write the equation. We can come up here, and we know that we'll have x squared over some number plus y in some shift squared over some number equals 1. That's just the generic form of all ellipses or circles. So as I look at this, I'm shifted right 2 units. What makes it go right 2 units? Negative 2, because it's opposite. What makes it goes down 2? A plus 2 here, because again, it's on the inside, so it's opposite. Now, we have a length going stretching each way, 3 units. 1, 2, 3, 1, 2, 3. Since I'm going 3 units both the directions, here and here, since that is 3 units that way, then 3 squared goes here, which 3 squared is simply 9. So 9 goes there. And now this distance is 1, 2, 2 that way, and 2 going down. So it'd be 2 squared here. 2 squared is actually, though, 4. So this would be my answer here. Let's try another. Part B. It says write an equation for the ellipse given vertices at 3, negative 4 and 3, positive 6. So we go right 3 and we go down 4 units. There's a vertice. And I go up 6 units. 1, 2, 3, 4, 5, and 6. There's a vertice. So that's the major axis because they're vertices. And it says foci at 3, 4. So at 3 up 4, we have a foci. And the other one is at 3, negative 2. Here. Now again, we could start off and we could find the center just because they have to be in the middle of these two. If you keep going up, we can find out that the center, it appears to me that if it has a height of 6 and a depth of negative 4, that's 10 units apart. So it'd be, they're 5 units away from it. The center will be 5 from each of these. So it should be right here. That's the center point. So we would say that C equals right 3, and it's up 1. You know, I probably should move this out of the way because later I'm going to actually draw my circle. So there's my center. As far as my equation goes, I can fill it in. I know it's going to be x minus 3. That's what shifts it right 3 units squared over something. And I know that it'll be shifted up 1 unit. So it'll be y minus 1 squared. And all this will equal 1. To find the denominator, I need to use the formula that connects the foci with vertices. It's kind of like the Pythagorean theorem. It's the formula c squared equals a squared plus, that is the Pythagorean theorem. This formula is a squared minus b squared. On the problem, we found out our c has a distance. It's 2 units away, 3 units away from the center. These are 3 units apart. Let me change this to red so you can see it easier. These are 3 units apart from there to there. So if these are 3 units, this distance from there to there is 3, then that means c squared would be 9. It'd be 3 squared, which is 9. There we go. The a is the distance from the center to a vertice, which we said earlier that's a distance of 5. So 5 squared would go here, which is 25. And now I can just solve for my b squared. So I subtract the 25, and I get over here negative 16 equals negative b squared, which means that b squared equals 16. Now you could say that b is equal to plus or minus 4. If you wanted to graph this, we now know that we would go left 4 units and have a covertice, and right 4 units and have the other covertice, and you could draw the graph if you needed to. But on this problem, it doesn't even ask us to graph it. All it simply asks us to do is write the equation. So we said that a is 5, but this formula calls for a squared, so you put a 25 here. And then the b, I'm sorry, I put this in the wrong place. It goes up and down 5, so the 25 should actually go here. The b is 4, so b squared would be 16. That goes with the x. And this would be our solution here. Now, I have this one for you to try.